and start defining where do you want this data to go to. Like, for example, into a company address. You can decide if you're going to do that by a keyword like company address, so you're not depending on location or something like that. And what you can see is that the environment is really giving you visual feedback. You can actually see where does the data go to and how. Very neat, very visual, very easy. You can actually go and do something more interesting, like this is where the table starts. So we can highlight that as a marker, then refer to the repetitive structure next. We can go ahead and highlight data and say that at this stage this is done by position, and we can map it to the desired place inside the schema. So very easy, straightforward process how to define the transformation. And once you've done that, this is really an option. This is when you're actually able to define I started from the document, from the PDF document. You're defining how to extract the data, and then this is actually, you're receiving the data already in a flattened format based on your schema. So we've seen the PDF example. I started from that because this is the hardest example that exists. Some of the value proposition actually comes from other areas. So if somebody needs to actually process on a Hadoop industry standard, then all of these drag and drop and visual thing that I showed you will still work, but you can actually leverage out-of-the-box transformation that Informatica has already supplied. So for industry standard like fix, if you want to do analytics over trades, we already have all the transformation. We're releasing yearly or bi-yearly versions depending on the changes in the standard. Those of you that are familiar with implementations, like in China Mobile for ASM1, call detail records processing on Hadoop, then call detail record is another complex binary format. Again, a library, predefined transformation available out of the box. If you're dealing with XML, JSON, Avro, and other hierarchical formats, there is a very deep support that allows you to easily map these hierarchical formats into a flat file. A lot of wizards, a lot of stuff into that. What Informatica did is really give you a very productive environment with a lot of predefined transformation, which we've already had for years and optimized for thousands of customers. And what we did right now is really made it available inside of it. That's it. I put here what we call a subset of the supported data formats. Everything you see here actually have tens of customers that are using it. It's not limited to just these formats. You can actually use much more than just these formats. But this is kind of a very common list of things that people are using this technology for. Since I showed all the drag and drop on the demo, I'm going to skip that from the presentation perspective. And this is the list of predefined libraries. And when I'm saying a library, predefined libraries means that we are supporting all the messages, all the versions, all the validation rules, all the structures, all the elements that exist in this industry standard. Some of the first implementation of Hadoop that I've seen dealing with trade data like fix actually work great, but the fixed standard is updated every year in the first quarter. So it kind of requires you to go into the Java or Perl code that somebody wrote to process the data and try to fix it. These are the things that we're supplying on a yearly basis in a push mode to the customers. Some of these formats are simple and straightforward. Fix is a name-value pair, but it does have hierarchy in the name-value pair. It does have more than that. So I wanted you to see these are kind of things that you can get out of the box from HParser. However, even when we're giving you something out of the box for industry standards, it's not necessarily enough. Very much like the Hadoop environment, the industry standards have many versions and a lot of compatibility challenges from time to time. So when you're actually looking into an industry standard, it's really critical that besides of the out-of-the-box capabilities and the updates that I've already discussed, you will be able to see that your data really works according to the standard, that it's not somewhat a variation of the standard, and that you can actually change the definition. make it more flexible, more strict, depending on your specific needs, and really enhance validation, so you're getting the data not just in the right format, but also with the right value and the right quality. So all of these are kind of additional capabilities that are built into the environment. So how does it work? The real secret sauce here is in the design environment, the way you're building and defining the transformation. Once you have done that, like I did, you're basically able to deploy the transformation and make it available inside the cluster. Basically, the HParser engine is installed across the cluster, and then the transformation are distributed using cache. This is actually enabling you to run a simple MapReduce call, the specific transformation that you were just creating. If this transformation needs an update, you don't need to update the whole MapReduce program. It's enough for you just to update the parser itself and redeploy or republish it. This will actually update and fix all the data issues. It does create a nice separation between changes to the data format, because the data format can change really easily, and the way you process the data, the way you want to handle the data. It also created great separation in cases that you're receiving multiple different formats, but they actually have the same data in them. Now you can actually have the same process handle all of these data formats, and depending on the format itself, you can actually activate a different parser that will normalize the data in a different way. No secret sauce here, no artificial intelligence, just a very visual, easy environment to define how to parse, and also a very, very strong debugging environment.
Can I ask you a question?
Yes, please.
So if you have three replications, so if the same will be parsed 3 times in 3 machines?
If you have 3 replication of the data, would it be parsed 3 times in 3 machines? No, the idea is that if you're calling a file, we're leveraging the Hadoop environment, so we'll process the file once. If the file is split across multiple areas, at this stage, this will be part of my future section, we'll process it as a single file. At this stage, what we're dealing with is, if the logic of the file is very complex, then actually the way it's split on the Hadoop cluster is not necessarily by record. So you might need to combine multiple portion of the file together. So right now you're aggregating the file, processing the file here. You can, however, process as many files in parallel as needed. So I answered your question and another one that I kind of hear a lot. Was that okay? I did want to go with you over a few examples, and these are things that Informatica have announced the HParser availability about 20 days ago. These use cases are kind of part of our beta use cases. Some of them are going into production right now. The first example is actually trade data. And what you see here is actually fixed, and you can actually very nicely see that when fixed data is coming, the first field is actually saying what's the value, what's the version of the fix, because there are actually many versions. These records, you can see, are variable length records, so not all the records are in the same length. They don't use any breaking characters between the different records. So first thing is, why process fix in Hadoop? Which is the question that I was asking the first users that came to us. The main reason is that the trades actually create a lot of transactions. And a lot of them are done automatically. These are huge logs coming from the trading systems. These trades are done on a daily basis, or are analyzed on a daily basis and on a monthly basis. But there's actually a lot of desire to do analytics in a retro perspective. So if you're reading in the newspaper about somebody from a certain bank that was actually trading and putting the bank in too much risk, how did that happen? What was done? How long did it go? How was that done versus the market behavior? This is a classical use case that actually require you to process a huge amount of data. Some of it is the trades that were done, but a lot of the other data is actually market data, what others were doing, how were they doing it, and so on. So part of the governance processes that banks are trying to put, and some of the control of risk that is trying to be put in place, Hadoop is a classical environment to do. If we're looking into why Hadoop, this next question is, Why is handling fixed data complex? Why do you need an environment, a visual environment like that to actually effectively process this data? So the first reason is variable length. Splitting the data needs to be done in a smart way, and it needs to be done based on understanding the records and the hierarchy of records. The second one is that the tags actually have a meaning. So the number 8 there in the beginning, or the first character, actually means version number. The number 9 means the trade number, and so on. So you can actually see that somehow somebody needs to translate that. There's also hierarchy in the records. There are records that are repeating within records, and so on. There are complex tools and trading tools that actually require different records, and so on. There are variations. And the main part of the variations is that every system that is out there can use tags that their number is higher than 500 in a proprietary way. So somehow you need to be able to translate their proprietary records. They're actually yearly releases, and even if you thought that you actually solved the fix problem, then the fix organization is brilliantly coming with XML, which is a new version, new structure, a whole new way of dealing with this data. Why? There is no good reason why. XML is a nicer way of putting the data, easier, but now for a few years you'll have to actually deal with both flat records as well as XML bases. I mentioned earlier telco, and everybody here in the room, every 7 seconds that you're not talking but listening to me, your mobile phone is actually creating a record. And this record is being captured in the nearest antenna or switch that exists somewhere. And this is all information that is being captured. This information is so huge that there's no way to move it from the switch into the billing system without actually compressing it. So what you're saying is actually how a record like that looks. And this format is called ASM1. And yes, it is as ugly as complex as it looks on the board. This is a real record. So CDR are large data set by default. When you're talking on the phone, you're actually creating a record every few milliseconds, because the billing is actually done in less than a second duration. So when there is a desire now in the mobile industry to give us more sophisticated options, personal bills, and so on, there is a need for more information here. Hadoop seems like almost the only environment capable of processing such a huge data in that level. So what makes handling CDR complex? When I created this slide, I thought it's enough to show the picture, because it is a nice example of data. But besides the fact that it's binary, it actually is using a format called ASM1, which to those of you that have white hair like me and have done some COBOL programming somewhere in your dark ages, then ASM1 is a more complex version of COBOL. It actually has a COBOL copybook version that says this is how the data will look like, and this is how the data is looking like. But different vendors actually are taking this ASM1 and creating their own version. And why would they do that? They do that because each vendor is actually giving you more new features. So if 3G was enabling you to do one thing on your phone, 4G enables you to do data and text at the same time, video didn't exist, SMS didn't exist 5 years ago, and so on. All of these are new things that you need to support. You need to be able to capture that. You need to invent new tags for that. This is really what you're getting. This is the variation that you're seeing from the vendor. And this also is getting updates. Whenever you update the switch on a software update, you can actually change the CDR data as well. I wanted to finish with a data that was built to be simple, but we have actually heard that that is one of the most common requests that we are hearing from customers for HParser, JSON data. So XML, JSON, easy to read, easy to consume, but if you're actually dealing with a very deep hierarchical structure and you want to normalize it, flatten it, it can actually create its own challenges. It's extremely common. A lot of the logs out there that people are processing on Hadoop are JSON logs. A lot of these logs actually require a lot of coding. And this environment is actually optimized to deal with hierarchical data, making it extremely simple to deal with it. So we talked about hierarchical flat files, we talked about JSON. XML is another format very common. In some cases, between the different pieces of the hierarchy, there is logic. So if something means, if there is a value, there's an insurance example I was dealing with lately that actually has a value that is that is actually, when you have a person, there is actually a value associated to that. That's telling you whether he's the one that made the accident, is he the victim, or actually the one that did the accident. Right? So the fact that it's under a person, and then there is a value in the properties that says 1, 2, or 3, have a whole meaning to the rest of the data. How do you translate that? This is kind of the thing that HParser is optimized to do. I'll open it to questions. Unlike some of the other people that have been here before me, I don't have the privilege of saying this is open source, but I do have the privilege of saying that a lot of these capabilities are available in what Informatica made as the community edition. Edition that is available for free for you to download from Informatica, including for free production usage. You're more than welcome to take it from the Informatica marketplace. If there are any questions, I'll take them now, and if people want to actually ask them over email or here's my contact information, I'll gladly get feedback and share more data with you.
I'm an business analyst using Hadoop from the analytical part of the world with the presentation. My question is, usually people currently don't have Informatica, we use Python or some scripting language to do their parsing. And what's your argument to persuade the user writing their own Python scripts, how you use libraries to use Informatica?
I'll say that I'll dare everybody here, if you wrote more scripts than I did. I actually wrote a lot of Perl scripts specifically, and a lot of Java code to parse. It's actually not something that you want to do. It wasn't something that I wanted to do. The reason that I joined this company 5 years before Informatica acquired it was because I thought if somebody can do parsing in an easy way, there is a market for that. I definitely would go that way. So argument is productivity, argument is maintenance. Data changes more often than the process. You actually want to be easy, you want it easy to maintain. This will be my key argument. The fact that you have a free version probably helps as well. I wrote it in Perl. It's actually not as easy.
It looks like a very nice tool, but just wanted to understand, like, how different is it from Talent or Camel?
So Informatica does compete with Talent and with other data integration products. None of them actually have a parsing tool. Most of them, their area of strength is actually how to take data from databases, how to take data from application and integrate them together. Informatica has a very unique capability. This HParser, as I said, it came from an acquisition about 5 years back. It's available as a standalone, running in Hadoop. Talent just doesn't have that. So I mean, they will not be considered competitive. I think to the last two questions, I'll say there is a competition. The competition is called encoding, and we all know how to do that. It really is up to how complex is the data and how many of that do you want to do. I think that is the value proposition.
So I'm curious, the code you're generating, is this completely running just, you're generating something that doesn't require any of your own libraries, or you've actually sort of embedded your own code, informatic code on each node that's being used for this?
So we have a very small subset of our code that is what I'll call the HParser engine that have been installed across the cluster. And what you're distributing every time you're creating a transformation is an XML file, a very small XML file that says how to process that specific file. So install the agent once, optimize installation for Hadoop, and then every transformation through cache is being distributed, and that's how it runs.
So I see that you actually support other formats, data formats, you support XML, PDFs, binary, blah, blah. So suppose we have multiple formats and then we want to use HParser, and then when we define data schema, do we need to follow certain rules or use a tool that you provided, or how do we, we have a syntax in order for us to define data schema?
No, the idea is that you're taking a lot of blobs. It could be PDF, Excels, and flat files, JSON, and so on. The schema is actually your desire of the data for the next step. So commonly I've even seen people that create a sample of that data. So you want comma delimited file, you want comma delimited data, these are the fields you want, you just put their names, you press the import button and you have the schema created for you. That's the easiest way to do it. Another one is we have an XSD editor, you can actually create your schema, it will give you the same thing. But there are no limits to the level, to the schema. You can create complex schema as well as simple schemas. Most of the people that I've seen using it on Hadoop actually create very simple schemas. And the complexity is in how do you break the hierarchical structure and flatten it into a simple structure.
My question is, are you providing controls on the scalability of running the HParser?
So how scalable is the solution? So one thing is, those of you that will email me, I'll forward you performance numbers. In general, what I would, in a very high level, I would say it's about 2 meg per second per core. That would be your ability to parse, and it is fully scalable by the number of cores that you are using. So you can kind of calculate the size of the data. I would put a disclaimer and say that if you're dealing with binary data, the performance will be a bit slower because there is a need to translate the binary format. But you can look into a ratio that goes between 0.5 meg to 3 meg per second per core as your overall performance number.
As a company, what's the commercial interest making? What's the company's interest? I mean, in terms of your business model, how does it fit into the?
Good question. That's the question that the vendor always fears of, especially coming to an open source community. So Informatica have 2 desires. The first one is we see Hadoop as a huge opportunity. I was in Hadoop World last week, and I think one of the things that I hear JP Morgan Chase saying is that since they have moved to use open source in Hadoop, they've bought more ETL than ever before, because the amount of data generated from here needs to go back into application and other places. So Informatica does see Hadoop as a very important trend to data integration. Specifically, what Informatica is looking is actually to have a basic version that is free, like the HParser Community Edition, and then premium capabilities like predefined libraries and things like that that will eventually charge for.
How do you define those libraries? How do you define those libraries? I think the question I'm asking in the background that if I have a customer and I recommend to use HParser, what risk we're taking in terms of future costs?
No, so I think the cost structure is actually pretty simple, and I'll go over it with you guys. So typically what we're saying is that if you're using XML, JSON, text files, the community edition will support that. If you're actually going to use things like Fix or PDF or things like that, where we're maintaining and releasing versions all the time, this is where the charge will be. There is a price book with all the prices for it, and it's pretty simple. So the idea is actually to charge for new content that they are receiving from us.
What I didn't understand, can it be used as a mapper?
Yes. So the question is, can it be used as a mapper to go from one structure to another? So yes, very commonly. So all the JSON XML, this is exactly what's being done. There is a function in there that's called HMap. It's the name and everything was before I learned about Hadoop. It's many years back. It comes from hierarchical mapping, and this is exactly the function.
So you just provide the jar and you just use the Java API to use it.
Correct. So thank you very much, everybody. And to those of you that have been here, if you'll mention that you've been here, if you have a specific file you want to look at, send it to me. I'll try to help you see it working in Hadoop.
So I think we have one last person I want to ask the group here a question. We are a users group, so I wanted to give one of our user members here an opportunity to poll all of you.
Thank you. My name is David McMillan, and I'm interested in connecting with people who have applications that need both OLTP and decision support in a time-critical environment. So, for example, if you have a big database and you're doing OLTP with a lot of updates, and you also want to do decision support queries against that database, I'm very interested in talking with you. So I'll just be up here at the front. Anybody who's got that kind of situation, want to make a connection.
So thanks everybody for coming. Thanks to our speakers tonight. And again, next month is the holidays, so no hug in December, and we'll be back here in January. Thanks everybody.